Hello, we are excited to share with you a lecture about LIDAR with the LIDAR expert. Would you please introduce yourself?
Hi, everyone. I'm Ken Seligson, an associate professor in the Department of Anthropology at Cal State Dominguez Hills.
Wonderful. So, what is LIDAR?
Great question. So LIDAR is originally an acronym for Light Detection and Ranging, but it has actually become its own word unto itself, and we use LIDAR today as just a word. And the original technology of LIDAR actually got its start way back in the 1980s, and it has developed over time, and it has been applied to archaeological research since the early 2000s. And basically what it is, in the form of airborne laser scanning, is you attach a small LIDAR instrument to a low-flying plane or helicopter or even a drone now, and it zigzags back and forth over a forest and emits over 150,000 radar pings per second in either ultraviolet or infrared light that zoom down, hit an object, and go back up to the sensor. And this is over 150,000 points per second that you're getting there. And so you get a readout of what the forest looks like below there. And so if you've been in a dense forest and you've looked up, most of the sky is blocked out by leaves and branches, but there are tiny holes between the leaves and the branches where you can still see the sky. And it's through those tiny holes that maybe 5 to 10 points per square meter get through the forest canopy down to the forest floor until we could get a readout of what the forest floor looks like. So you see in this cross-section image that most of the points hit the top of the tree canopy, and you get a readout of the vegetation, and that's all those green points. But you can also make out multicolored points below there that hit the forest floor back up to the sensor. And it's using those that we can stitch together different points to make a digital terrain model, a digital version of the forest floor, and triangulate what that looks like. And so this is airborne laser scanning LIDAR, but LIDAR is also in some of your cars. If you have a car that beeps when you start leaving your lane, or you have a car in front of you, that's LIDAR in your car. There's also terrestrial LIDAR that you see in the middle there that we can use to scan caves and wells and tunnels to get a readout of what those look like. So it's also used in spatial mapping on the ground.
That's wonderful. So, how do you use LIDAR in your research?
Great question. So where I work in the northern Yucatan Peninsula of Mexico, the terrain, the landscape is super forested. So there's a site right there in the middle of this image, and you can't even see it. Even if you flew over with a Google Earth satellite, you would not be able to see many of the archaeological sites. So if we use a LIDAR airborne laser scanning flyover, you'll get all of these points that show you the canopy of the forest and an orchard in the northwest corner and a recently planted cornfield in the bottom right corner of the image. But if you remove those 99.99% of the points that hit the trees and the other vegetation, what you're left behind with is a map of the forest floor below. And in this case, you have hundreds of archaeological features, all these geometric shapes. And this image is about 2 kilometers across. You have a small pyramid, a 110-foot long structure along the western side of the image, and a marketplace in the southwest, and the suburban sprawl of this ancient site. So basically, airborne laser scanning allows us to map all of these massive areas of archaeological sites in a very short span of time, whereas we used to have to walk back and forth across the jungle floor. And this is the basic start of things. We also have to do some processing of the data. Sometimes there are a little bit of holes where maybe there was especially dense foliage, or where there's an anomaly that the LIDAR machine doesn't really pick up as being an archaeological feature. For instance, right here, you have a little bit of a hole there. And that's because there was a standing structure there. And so the LIDAR scanning did not read it as an archaeological feature or the forest floor. It thought it was a standing modern building, but it's in fact an ancient building that's still standing. So in some cases, we can use different processing techniques. In this case, it's a very aggressive differentiation between the vegetation and the ground floor, and you get some little anomalies there. So we can use a less aggressive form and it gets rid of those little anomalies. So there's some processing that we can do on our end, but a lot of the processing is done upfront by LIDAR specialists, for instance, at the National Center for Airborne Laser Mapping at the University of Houston.
Wonderful. I also have other questions. So, what type of things we can learn from LiDAR?
Super important question. So for instance, where I work in the northern Yucatan Peninsula, we can use LIDAR as a baseline for understanding settlement patterns. We can map where platforms are to get a readout of where sites are located and see them in relation to each other. So you can kind of get a heat map of where you have site clusters. And in this case, we have these pretty large sites, only about 4 kilometers apart from one another during the classic period of the Maya civilization, about 600 to 900 AD or CE. So we can see land use patterns. We can see site interconnectivity in the form of causeways that connected different sites across different regions. Both within and outside sites, we can see these kind of connections going on by seeing these causeways, which are very hard to see on the ground because they're so low. We can look at water management, and water management changes over time. In this case, in the center of this image is a massive reservoir. And we can see these across the landscape. This was one of the ways that the first settlers were able to actually establish a foothold in this region where there are no other surface water resources like rivers or streams or lakes. They had to build their own reservoirs to survive there. And we can also use LIDAR to see areas that may have been destroyed or archaeological features that may have been destroyed. Because if you can see in this image, the vegetation today is pretty much covering elevated land. And on that elevated land, you have all of the archaeological features. But in the eastern side or the right side of the image, you have a patch of raised land that does not have any archaeological features, and it's actually being used as a milpa field today. But this tells us that this very well may have been part of the archaeological sprawl of this site, and yet the archaeological features may have been moved by modern developments in the last couple of 100 years.
Wow, that's amazing. So, when or where in the world archaeologists use LiDAR today?
Yeah, great question. So we're obviously using it in the Maya area, which is heavily forested, and LIDAR is a game changer. It's not an overstatement to say that the LIDAR revolution has really changed what we've been doing in Maya archaeology over the last 10 to 15 years. And all these little yellow patches are places that have already been scanned by LIDAR. And who knows, in the next 20 to 25 years, maybe the entire Maya area is going to be LIDAR scanned. But even in areas without dense forest vegetation, LIDAR is super useful. In southwestern England, they've LIDAR'd the area around Stonehenge to see how it was part of a much broader ancient landscape that included earth henges, wood henges, and you can see that a lot more clearly with the neutral tone of the LIDAR digital elevation model compared with the modern satellite image. They've used LIDAR over Angkor in Cambodia. This is the center part, Angkor Wat, and you can see little patches where there were buildings all around the central area, and then out beyond the central temple precinct of Angkor Wat, you can see pretty much how large the city was and how far it extended using LIDAR. And most recently, earlier this year, 2024, there was a big LIDAR scan that was published from the Western Amazon in Ecuador that showed these large, complex urban centers all across the Western Amazon, which is something that we expected would eventually be uncovered, and now it is actually being found using these LIDAR flyovers. So look for more stuff coming out of the Amazon in particular, but all around the world, LIDAR is being used to scan broad landscapes to see these ancient landscapes as large pictures.
That's great. So, what are the limits of LiDAR? Does it have like limits in its application?
Yeah, for sure. I mean, we could get lost looking at LiDAR images. I could be in my office looking at a LiDAR scan for days because it's so interesting. But we do have to remember that there are limitations to what LiDAR can do. For instance, it does not capture everything. Here's a tiny site called Paso del Macho near where I'm working in the northern Yucatan. It just shows you the center of the site, these 9 little structures there that you can see. But LIDAR does not pick up the 80 or so small house mounds that are located around the outside of the valley. These were only found by doing a walking survey, old-fashioned pedestrian survey, tiny clumps of stones that represented the foundations of ancient residences. These are just too small for the LIDAR to pick up. So we have to recognize that the LIDAR does not capture everything in its images. And also we have to recognize that what we're seeing in the LIDAR images is really the last version of this archaeological site. These buildings that we're seeing might be burying thousands of years of earlier cultural constructions, and we're just seeing what's on the surface. So we have to remember that however amazing LIDAR is, it's really just a starting point to then do further archaeological investigations.
Wow, that is amazing to know. Yeah. Thank you so much, Dr. Ken Seligson. And this is very informative session about LIDAR. Thank you so much.
Thank you so much, Amr. This was a great opportunity to share how LIDAR works and what we use it for. I appreciate it.
Thank you.